Hello guys, welcome back to Zaf Academy. So today I'm going to discuss with you about the chapter Trigonometry, which is the new entry in the grade 9 and grade 10. So before we sneak into the details and the questions of this chapter, let us first of all go back and discuss about the Pythagoras theorem. The theorem was very simple. It was targeted on the right angle triangles only. So let us take one same example that the triangle ABC is given to you, which is right angled at B, and by Pythagoras theorem we can say that the sum of the squares of the two sides will be equal to the square of hypotenuse. In this case it is AB square plus BC square is equal to AC square. If we can take one example here, let's see that if AB is equal to 3 and BC is equal to 4, these are given to you, the sides measurements, you have to find out AC, which is the hypotenuse in this case. So we can simply use this above theorem, input the values, get the answer. So in this case our hypotenuse is equal to 5. Okay, so this was the Pythagoras theorem. Now let's say we are having a similar triangle once again, which is right angle at angle B, and this time you are given one angle measurement. That is, let's say that here angle C is given to you, which is measuring 60 degree, and one side measurement is given to you, AB is equal to 3, and you are asked to find out the remaining sides and angles. Okay, so how can we proceed ahead in this case? I think so the angles will be measured out quite simply, because two angles are known to us. As B is right angled, it will be equal to 90 degree. C is 60 degree given to you. So A can be computed as 30 degree, right? But what about the other sides, AC and BC? How can we get the side measurements? So for getting this side measurements, we shall be using the trigonometric identities. Let's see them in detail. First of all, before we start discussing the trigonometric identities, I would like you to pay attention to this thing, which is very important if you want to learn the trigonometric identities. That, let's say, once again that same triangle is given to you, ABC, which is right angled at angle B, and let's say that we have one angle to focus here, that is C. Let's pay attention to this. Let's say that AB is the side which is located exactly opposite to the angle C, and let's call it that it is the side opposite to the angle C. And similarly, if you focus on the side BC, it is attached to angle C. In other words, we can say that it is the adjacent side to angle C. We shall be using these terms, opposite sides and the adjacent sides, to write down the formula of the trigonometric identities. So this triangle is basically very important for you to understand that what is the opposite side, what are the adjacent sides. Okay. Remember one thing, that here you cannot consider AC as the adjacent side of your angle C. Why? Because AC is the hypotenuse, it is not the side. So whenever you come across this theory, you should remember that AC is the hypotenuse. Here it is named as AC, but you have to make sure that this is the inclined side of right angle triangle, and it will be the hypotenuse, so you should not count it as the adjacent side to angle C. Okay, so now we are good to go to discuss about the trigonometric identities in detail. I will be drawing this triangle for you for the reference, and I have also highlighted that which is the opposite side, which is the adjacent side, and which is the hypotenuse. Okay, let's begin. The first trigonometric identity, sine of angle C. The formula goes, it is opposite side of angle C divided by the hypotenuse. In this case, the opposite side is AB, hypotenuse is AC. So in this case, your formula will be AB divided by AC. Similarly, if we discuss about the second trigonometric identity, it is the cosine of angle C, which is the adjacent side to angle C divided by hypotenuse. And the third identity is tangent of angle C, which is opposite divided by adjacent side to angle C. Okay. Once you are well aware with these three identities, the remaining three becomes very easier and simpler for you. Why it is like that? Because the remaining three are nothing but the reciprocals of the above three identities respectively. Okay, let us see them in detail. That cosecant of angle C. Now this identity is nothing but the reciprocal of sine C. So if you are writing down the formula of your sine of angle C as opposite side of angle C divided by the hypotenuse, the cosecant will be determined as hypotenuse divided by the opposite side of angle C. I have also mentioned here that it is the nothing but 1 divided by sine of angle C. Similarly, the secant of angle C is the reciprocal of cosine, and the cotangent is the reciprocal of tangent. So I think so you should focus on the first three identities, and the remaining three will be derived from the first three identities as the reciprocals of one another respectively. Okay dears, so let's proceed ahead. You should also learn the abbreviations because that is the thing we shall be using when we are discussing the questions and the problems. So sine of angle C will be determined as sine C, S-I-N-C. For cosine it is cos. For tangent it is tan. For cosecant it is cosec. For secant it is sec. And for cotangent it is cot. And to be honest, to make it clear, here our focus was on angle C. That's why my every formula is consisting of angle C only. Okay, you should know one more thing. Then if we are writing sine C, cos C, tan C, that does not mean that we are actually multiplying our angle with the trigonometric identity. It is actually the representation. Means what? We are basically calculating the value of the identity with respect to the angle C. That's why we are writing them in terms of angle C. So you should be aware that it is not the multiplication, it is just the reference of the angle we are giving to the trigonometric identity. Okay dear. So I think so the trigonometric fundamentals are covered in this topic, but I would like you to also see about the practical applications of this concept, because I have come across several instances where students tend to get bored of this chapter, or they try to find out the ways where they can eliminate this chapter. But I would suggest that you should not do this thing, because this concept has a variety of applications in the real life. Some of them I am discussing here in this slide, so please pay attention. And before you decide whether you want to skip this chapter or not, please go through these applications, and even you can search these things on internet. You will get a lot of ideas, and then you can make your own decision. Like I said that the height of the structures like mountains and plateaus can be determined easily using this trigonometric concept. Similarly, if we go ahead and say that sound engineering, aeronautics also has the concept of trigonometry involved, because in sound engineering the fundamental identities like sine and cosine functions, they are utilized to develop the simple computer music. So the music which you are hearing today, it is basically derived or created using the trigonometric identities in some way or the other. It does not have the direct applications, but yeah, the trigonometry has been the part of the sound engineering. Similarly, in aeronautics also you should consider that the flight motion, the flight path, is all of these things are basically using the concept of trigonometry. Also, if we see ahead, the gaming industry also has the applications they are taking from the trigonometry concept. The games like Mario, which the example I have given here, they basically use this concept of trigonometry. Navigation, when you are navigating in ship or even aircraft, trigonometry has its application involved there as well. Even in the marine engineering, marine biology, trigonometry has its concept applied. The distance or the size of the vessels or the ocean animals can be calculated by using this concept. Even the construction industry has been utilizing the concept of trigonometry for determining the perpendicular walls, for constructing the parallel walls, for designing the inclined roofs, and even once again the building height, which can be measured using this concept. So I believe you take a decision in a wise manner. I would suggest not to ignore this chapter, and this is not that much hard. Yeah, it is a new thing for you, so you might be somewhat confused or it might be seem boring, but in the end, it is the chapter which you must focus on. So that's it, guys, for today. We shall be meeting again, and we shall be discussing about the questions and the practical work problems related to this chapter. Till then, stay tuned. Wish you all the best for learning, and please do not forget to subscribe to our channel. Thank you very much.